So, as mathematicians, the order in which we do things is incredibly important. And I suppose this is really relevant because I feel that these sort of questions go around on, the TikToks and the different apps, and I'm sure you have all seen them. But this idea of kind of that the result we get depends on the method we follow or kind of what order we do things in. And I suppose it's reasonable to kind of have those discussions on, oh, I got a different answer because I did it this way or I did this part first. And obviously that's reasonable, and kind of understandable, I suppose. But naturally, maths is so ordered and quite, I don't want to say rigid because it's not, but it's quite systematic, and there's a format and there's rules and there's logic, I suppose is the best word. But logic is kind of behind a lot of the things that we do in maths. So the same goes for the order in which we do our operations. There's kind of a defined order that we tend to follow, or kind of a hierarchy in terms of the calculations that are done. And your calculator, for example, will follow this without you having to specify it. So when we do a sum, or when we see people kind of posting things online that they've done a sum in a certain way and their calculator's given them a different answer, it's often that they just haven't followed correct order of operations. There is also cases where the sum is simply poorly defined, okay, to kind of just create discussion, I suppose. It's kind of clickbaity, really. So maybe this sum has just been kind of poorly defined. They haven't really gotten into the kind of, yeah, they haven't just used the correct tools, or haven't written the sum in a kind of meaningful way to allow people to do it in the order that's intended. So that can often come down to the use of brackets and kind of separating out different parts of the sum, to allow it to be better understood. Okay, but I suppose for us, what we want to look at is, what is this order of operations? So obviously the operations we use in maths, the typical operations we would encounter are kind of like adding, subtracting, multiplying, dividing. These are kind of our main operations. They have inverses, so adding and subtracting are kind of the inverse of each other. Dividing and multiplying are the inverse of each other. We could even bring in square roots and squaring, or powers and kind of roots of those powers, and kind of those idea of those extra operations we can use. And what we're going to use to help us remember the order of these operations is the acronym of BIRDMAS. Now, it's a different acronym than you might be used to. There's loads of different ones. You can use BIMDAS, you can use BOMDAS, you can use GEMS. I've seen loads of different ones. And really, it is kind of whatever works for you. It kind of does affect maybe our understanding a little bit. We just have to remember what all the different parts of it stand for. And I've laid it out in this way because we do take them step by step. We follow through them in that kind of well-defined order, taking each operation as we come to it, with very few, but there are a few, very few exceptions. So what we do first is we do our brackets. If there is a calculation to be done inside brackets, we do that first. If there are more than one calculation inside the brackets, then we will still follow through with the same idea. If there's more operations to be done within the brackets, we'll follow that same order to decide which operations to do first. After brackets, we look at any powers or indices, and we look at any roots. So indices are powers, power of 2, power of 3, power of 4. They tell us to multiply something by itself a certain number of times. Roots is kind of the opposite. We're looking for numbers that do multiply by themselves to give us the number that's under the root. Dividing and multiplying, that comes next, and then adding and subtracting. The key thing about this stair idea is we're kind of going down the stairs, but when we land on a step, we do whatever appears on that step. So dividing and multiplying, they're considered kind of equal operations. So neither is more important. So what we would usually do is we just work from left to right, and whichever we encounter first, we'll do there. Okay, generally, if we've done the sum correctly, it shouldn't actually make a difference if we did decide to kind of deviate from that a little bit. It should all kind of follow out, because you kind of get into kind of the commutativity and associativity and all of these different things for your operations. But really, we just need to follow this order. So brackets, indices and roots, division, multiplication, addition, subtraction. And it may be helpful for you to kind of write this down the side as you're working through these questions. Obviously, when we get into kind of calculator work and things like that, this maybe becomes a bit less useful for us. But I think it's still important or useful for us to know, what is a calculator doing behind the scenes? Can I understand why the operation has been done in that way? So let's look at the first example here. We're kind of making sure or keeping a guide at the side here. So I'm just going to write it at the very side for myself. So let's start with the first one. First one, I look for brackets. I don't have any brackets. The next thing would be to look for any indices or roots. I do have indices here. So indices means powers. So in this one, we do have 2 to the power of 2. That means 2 multiplied by itself twice. So 2 by 2, which is 4. So we have 4 times 3 plus 4. So that is the only sum I am going to do on that line. When I move into the next line, I'm going to look for any multiplication. Obviously, I have 4 times 3, which is 12. So we'll do that next. So 12 plus 4. The next line is for addition. So 12 plus 4 is 16. So my answer is 16. So I'm doing one step on each line, or I'm doing the relevant steps on each line. Generally, that's kind of just one, but I'm not doing any operations from the next line until I get there. And that, I suppose, is allowing me to keep everything ordered. I'm moving my way down as well, which again, I suppose, just helped me to keep things ordered. Next sum, I do have brackets, so I need to do that sum first. So 4 plus 3 is 7, so I'm going to do that sum and then continue onwards. I don't have any indices or powers, so I can kind of skip over that line. The next step is divide or multiply, so we work from left to right here. 7 times 3 is 21. 4 divided by 2 is 2. Now we have 21 minus 2, which is 19. Okay, and we can get into some work with integers and everything and all of these as well, but really what you'll find is a lot of this is going to kind of still apply with integers as well. Okay, even if we consider our integers here, it's not going to change a huge amount as to what we're doing. We go into the next case. I have got brackets here, so we'll sort the brackets out first. So that's going to be 3 times 4, which is 12. Next step is indices or roots. I do have a square root here. It's the square root of 9. That means a number that multiplies by itself to give me 9, which in this case is 3 minus 24 divided by 12. Let's go for the next one. Divide or multiply. I do have some dividing. 24 divided by 12. That's going to give me 2. And then we can sort out our sum. 5 plus 3 is 8, minus 2 is 6. And we get our overall answer. Okay, just really, really important to kind of follow through these questions as best we can in as kind of ordered a fashion as we possibly can. So what I said was there's only very few exceptions to the rule here. So I'm nearly going to jump straight down to these exceptions kind of down at the end here. So looking at the first one, okay, less of an exception, more just kind of further steps to be done. If we look at the brackets, we can see that in the first bracket, there are more than one sum to be done. We have 5 times 9 plus 4. So to decide what to do, we still follow our same steps. So if I lay them out here, it's that bird mass idea. So we do brackets first, but then it would be roots, it would be multiplying, dividing, and then it would be adding and subtracting. So if I just do that one step at a time, 5 times 9 is 45, but I still need to add the 4. And in the other bracket, it's 1 plus 6, which is 7. 45 plus 4 is 49, of course, which needs to be divided by 7. I have no indices or roots. Now I'll do my division, which is 7, and that is my answer. We can see how there was 2 steps to be done inside the first bracket there, and we followed the same order. We still started with the multiplying and then did the adding. Looking at the next one, I suppose the reason I would consider this an exception is that a fraction does really represent divide, but obviously even though divide does come up early in the list in the order of operations, we're not going to do it quite early on. We need to get to a point where the division is the only thing that's left to be done. So even though it does come up early, we're going to kind of skip over it for a second. We have no brackets. We do have powers to do. So 5 squared is 25. So 3 times 25 over 15. We can look to see as they're dividing or multiplying. There is multiplying to be done, which is 3 times 25, which is 75 over 15. And then we might consider the dividing that comes from the fraction there. 75 divided by 15, and that actually gives us 5. Okay, a further example of that comes up in part G here. Same idea again. We'll start with brackets. So 8 squared minus 32 divided by 4 over 2 times 2 plus 1, which is 3. We'll go with indices and roots next. So I do have some powers. 8 squared is 64, minus 32 divided by 4, 2 times 3. It's very tempting to try and do a few of these sums at the same time, but we're not going to. We're going to work through it slowly. Dividing and multiplying should be next, but we do know that the overall division in the fraction we are not going to do until the very end. So 64, 32 divided by 8 is, or 32 divided by 4 is of course 8. All over 2 times 3 is 6. Adding and subtracting should be next. So adding and subtracting there, 64 minus 8 is 56 over 6 here. And we can't go whole pile further than that, I don't think. We can get down to 28 over 3. Last one to do here, we have a nice square root. But again, even though it's second on the list, we can't know what we're taking the square root of until we've worked out everything else that is underneath. And I suppose one way of thinking about that is it's nearly like there's a large bracket here that we have to sort out first before we're able to do that square root at the end. So we're going to sort out the middle term. We'll start with the brackets. So keeping the square root over it all, 3 plus 5 is 8, which needs to be squared, plus 9 times the square root of 16. Next is always our indices and roots, so let's do that. So do we have any powers? We do. 8 squared is 64. Do I have any square roots? I do, which is 4. Do I have any addition or division or multiplication? I do indeed. So let's look at that next. 64 plus 9 times 4, which is 36. Do I have any addition or subtraction? I do, of course. I can add my two numbers to get 100, and now I can do the square root, which gives me an answer of 10. So even though it should have been earlier up our list, obviously we couldn't calculate it until we knew what we were doing the square root of. So just that idea, I suppose, of kind of holding off until we're really, really clear, until we've worked through the whole thing and are sure of exactly what it is we're doing the square root of, or what it is we're dividing in those fraction questions. And besides that, just following the order to the T. If we have two operations which are equal, where they could come like dividing and multiplying, we could do either, then we generally just go from left to right and do whichever one comes first. We maybe avoid doing too many steps on one line. Obviously we don't do any more than just the operations that appear on the same step here, but ideally if we can kind of spread it out, that's going to avoid you making any further mistakes there. But besides all of that, it's just remembering that bird mass idea. That's really going to help us to kind of keep things in check and to kind of keep that order on lock.